A distinction in Euclidean geometry starts with you understanding the basics. There are things called angles and lines. The angles on a straight line, they always add up to 180 degrees, and always put your reasons saying angles on a straight line or adjacent angles on a straight line. There are other things called angles around a point that always adds up to 360. You can say angles around a point or revolution as your reason. There are also vertically opposite angles. They are always equal. This angle here and the angle here, they are equal. Your reason being vertically opposite angles. Let's continue with our journey towards a distinction in Euclidean geometry. When you see parallel lines, there are three things you should always look out for. The alternating angles, how do you spot them? They form a Z shape or N shape. The angle here and the angle here are going to be equal. The angle here and the angle here are going to be equal. Don't forget that everything in Euclidean geometry happens for a reason. Reason being alternating angles, line AB is parallel to line CD. Provided that you're going to use the exact names of the lines that you are given. I just used AB and CD. There are other angles called corresponding angles. How do you spot them from far is that they form an F shape. Having this angle here and this angle here being equal. The reason for them is going to be corresponding angles. Line AB is parallel to line CD. There are other things called co-interior angles. They form a U or a C shape. The angles inside them, they add up to 180 degrees. These two, the angles inside a Z or N and inside a F, they're equal. But U and C, they add up to 180 degrees. The reason being co-interior angles, line AB is parallel to line CD. Whenever the examiner mentions anything about parallel lines, just consider these three things. They are your three tools to use. 1, 2, 3. Your distinction in Euclidean geometry starts understanding that there's always triangles involved in Euclidean geometry, and whenever the examiner says anything about triangles, consider these 4 reasons. The first reason being the sum of the angles in a triangle. They always add up to 180 degrees. You can put a reason as sum of angles in a triangle. Whenever you are solving for any angle inside a triangle, your reason can just be sum of angles in a triangle. The other second part is the exterior angle of a triangle is equals to the two opposite interior angles. Let me show you by using a diagram. Please, I did not use a ruler. Do not attack me for it. They are saying that the angle here is equals to the ones that are opposite it here and here. This angle here is equals to this plus this. Do you understand? Your reason is going to be exterior angle of a triangle. The third thing that you must look for whenever they talk about triangles is that, is your triangle an isosceles triangle? Angles opposite equal sides are equal. This is what I mean. An isosceles triangle, first of all, what you must remember is that it's a triangle with two sides that are equal. This side and this side that are equal. This side is not equal to any of them. Now, they are saying that the angles opposite equal sides are equal. This angle here and this angle here are going to be equal always whenever they are talking about an isosceles triangle. When you are giving out the reason, your reason is going to be angle opposite equal sides. The angle opposite equal sides. Then the other fourth thing that you must always look for is when you have an equilateral triangle. Equilateral triangle is basically a triangle with all the sides that are equal. This side and this side and this side. They are all equal. Therefore, you're going to have equal angles to 180 divided by 3 is going to give you 60. Meaning each angle here is going to be 60, 60, 60. Always. Your reason is going to be equilateral triangle. Your distinction journey continues as you know that there are things called congruency and similarity in Euclidean geometry. Congruency simply means the same, similarity simply means proportional. Let's get into the details. Congruency, you will always see it with the sign, and it can happen for 4 reasons. If you have 2 triangles, let me make an example. 2 triangles, and this triangle, this side is equals to this side, this side equals to this side, this side is equals to this side. It means that they are congruent, and remember that everything happens for a reason. Therefore your reason is going to be side, 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 or SSS. Then if you are given 2 triangles like this, and this side and this side and this, they are not equal, I'm just showing them bigger, and this side and this side, and maybe one of the angles are equal, this side being equal to this side and this side being equal to this side, and maybe an angle in between them being equal, therefore they are congruent. There isn't going to be side, angle, side. Don't forget that everything happens for a reason. If you are given 2 triangles and we are given that this angle equals to this angle and this angle equals to this angle and this side is equals to this side, therefore they are congruent. Your reason is going to be angle, angle, side. Then when you are given a right angled triangle, a right angled triangle, let's say you're given 2 triangles and they both have a right angle, they both have a hypotenuse, and they both have an equal side, therefore they are congruent. The reason is going to be RHS, meaning right angle, hypotenuse, and side for right triangles. Then we go again. Don't forget that there are 2 things. The second thing is going to be similarity, and it is shown by 3 vertical lines that are close to each other. If 2 angles of one triangle are equal to 2 angles of the other triangle, the third angle is automatically equal, making the triangles similar. If these triangles here, this angle and this angle and this angle and this angle are equal to this angle and this angle, meaning automatically we are saying that this and this are going to be equal. That is going to be similarity. Your reason is going to be angle, 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 or equiangular, or you can write it by angle, angle, angle. Don't forget, there is no angle, angle, angle here. Angle, 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 it means similarity. The distinction journey continues in Euclidean geometry by knowing that there's something called the midpoint theorem. If you have a triangle like this, and then you put a point right here, and then you put another point right here, then you draw a straight line like this. The midpoint theorem is telling us that your new line runs in the exact same direction as the bottom line. This bottom line is like this, is going horizontally. Your new line too is going horizontally. They are perfectly parallel. They are parallel, meaning if there is any shapes of any triangle inside, you know what to expect. If there is any lines inside, you know what to expect. On the previous videos I've explained it. The new line is exactly half of the bottom line. This line, if this line was 10, this one is going to be 5. If this line is 6, this line is going to be 12. It's exactly half of the bottom line. It cuts the side exactly at half. If this full line was 10, meaning the distance from here to there is going to be 5, the distance from the midpoint to down is going to be 5. If the distance here was 18, the distance from the midpoint to the up vertex is going to be 9. The distance from the midpoint to the down vertex is going to be 9. And there's also something called the converse of a midpoint theorem. The converse of the midpoint theorem, which is converse, simply means the reverse. The midpoint theorem is saying that you must draw 2 points, join them with a line. Automatically this becomes parallel to this, and this becomes half of this. But now the converse is saying that you draw only one dot. After drawing only one dot, and then you draw a line exactly where your line is going to touch the triangle, that is your midpoint. That is what the converse is telling you. Wherever where the dot, you draw a line from a dot, wherever it's going to land on the other side of a triangle, you have found the exact half of that side, which is the midpoint. That's what the converse is basically saying. The distinction journey in Euclidean geometry continues, as you know that there are properties of quadrilaterals. An examiner can put any quadrilateral that they want as part of Euclidean geometry just to shake you a little bit, but do not be shaken, because here are the properties of the shapes. If you have a parallelogram, just know that the opposite sides are equal and they are parallel. A parallelogram, it means that this side and this side, they are equal and they are parallel to each other. Know that if you have a parallelogram, this and this are equal. This here and this one here, they are equal. The angles opposite each other are equal. The diagonals cut each other exactly in half. If you have diagonals inside your parallelogram, exactly where they cross, it's half the distance of both of them. And then if you have a rectangle, let's draw our rectangle. They have the same rules as a parallelogram, which is the diagonals, the angles, the opposite sides that are equal to. And also it has 490 degrees. All the corners are 90 degrees. If there are diagonals each are inside, they are equal in length. If you have a rhombus have the same like a parallelogram. What is different about the rhombus is that all 4 sides are equal and they cross each other exactly at 90 degrees. Wherever they cross each other, just know that if you have a rhombus, if there are diagonals inside, wherever they cross inside, it's going to be 90 degrees. A square have the same properties like a rectangle, forgive me. A square has the same properties like a rectangle. Let's remember our properties of a rectangle. Our properties of a rectangle, the diagonals have the same length. They are equal in length in square too. They have 490 degrees. We have 490 degrees. And we have the same as parallelogram, meaning the angles opposite are equal, which is the truth, 90-90. The opposite sides are equal and they are parallel. This side is equal to this side and they are parallel, and this side is equal to the side and they are parallel, and all 4 of them are equal, but they are not all 4 parallel to each other. Only 2 is parallel to each other. Kite. If you have a kite, you're gonna have something like this. The 2 top sides are equal. The 2 bottom sides are equal. If they are diagonals inside, they cross each other at exactly 90 degrees. And then a trapezium. Sorry, I did not draw it according to scale. Let me try drawing it again here. Yeah, I tried. Yeah, something like that. A trapezium says only top and bottom side are parallel. This side and this side are. They are parallel to each other. Therefore, when an examiner says anything about any of these shapes, do not panic. Just get to know each and every one's properties, so that when an examiner takes them out on an exam, you don't have to panic. You know all the reasons for each and every shape. The distinction journey in Euclidean geometry continues as you get to understand all these theorems. There are 3 theorems that talks about the center and the chord. Line from the center to the chord or past the chord, either one. Let's get to know each and every one of them. Theorem 1 states that a line drawn from a center of a circle to a chord cuts it exactly in half or bisected. In half means bisect. Theorem 2 states that the angle at the center of the circle is exactly twice as big as the angle at the circumference if they stand on the same arc. If only they stay on the same arc. If they're not in the same arc, Theorem 2 does not apply to that diagram. Then we have Theorem 3 that states that an angle sitting outside a semicircle is always a 90-degree angle. The distinction journey continues as you get to know that there are 3 theorems that talks about cyclic quadrilaterals. Cyclic quadrilateral is a 4-sided shape with all corners touching the edge of the circle. If all 4 corners do not touch the circle, they are not a quadrilateral. Theorem 4 states that angles on the edge standing on the same segment are equal to each other. Again, Theorem 4 states that angles on the edge standing on the same segment are equal to each other. Theorem 5 states that the opposite interior corners of a cyclic quad adds up to 180 degrees or are supplementary. Supplementary means we're adding up to 180 degrees. Again, Theorem 5 states that the opposite interior the corners of a cyclic quad, the opposite that are inside, they add up to 180 degrees. Theorem 6 states that the exterior angle of a cyclic quad is equal to the opposite side corner. Again, the interior angle of a cyclic quad equals to the opposite inside corner. The distinction journey continues in Euclidean geometry when you get to know that there are 3 theorems that speaks about tangents. Theorem number 7 says that the tangent line is perfectly perpendicular, which means 90 degrees to the radius at its meeting point. Where the radius and the tangent meets, that is a 90-degree angle. Theorem 8 states that 2 tangent lines drawn from the exact same outside spot to the circle are equal in length. If 2 tangents are drawn from the exact point, both of them are from a single point, and they are both going to the circle, they are equal in length. That's what Theorem 8 says. Theorem 9, which is called the tan-chord theorem. The angle between a tangent and a chord is equal to the angle in the same triangle segment. Again, the angle between a tangent and a chord. Where is the angle between a tangent and a chord? Is equal to the angle opposite triangle segment. The distinction journey in Euclidean geometry, when it comes to all the theorems, you must know what exactly are they talking about. The dot inside a circle, that is a center. A line drawn from the dot towards the side of a circle, that is called the radius. A line drawn from the side of a circle towards the other side of a circle and it passes through the center, it's a diameter. A chord is a line that doesn't pass through the center. It passes somewhere. Here, can be here, it can be here, it can be here. That is called a chord. A sector is when you have something, a diagram drawn in this exact shape. Everything inside it, it's a sector. When you have a line drawn like this, everything under here, it's a segment. An arc, it's a small round distance around a circle. A circumference, it's a full side of a circle. A tangent, it's a line that touches the circle only once. It must touch the circle, not twice, just only once. A secant is a line that passes through the circle on both sides. Passes through. Now that you know what is what, let's try to visualize all the theorems in a paper. Forgive my drawings are not drawn to scale. Theorem 1 states that if a line is drawn from the center towards the chord, therefore it bisects or cuts that line into two. It cuts the length or the distance of that line into two. What is a chord? A chord is a line that can cut like this, like this, like this. Let's be dramatic and put it by the side because we can. Why not? Then theorem 1 says that if you have a line drawn from the center and it touches this, meaning it bisects it, meaning if this line was 9, this side is going to, if this line was 18, this line is going to be 9, this one is going to be 9. And automatically, if that forms anything else, if you have to solve for a side that is going to be here or here, you're going to have to use the theorem of Pythagoras, because when this and this, when the line drawn from the center bisect the chord, it is therefore perpendicular. Perpendicular meaning it is going to form a right angle like this. That's why you can use the hypotenuse theorem. The same this side.